Thinking of going solar? You need to know this first.
T-minus 10, 9, 8, 7, 6, 5, 3, 2, 1, 0, and liftoff of Space Shuttle Atlantis.
Hello and welcome. Today we're focusing on a critical aspect of renewable energy, the fire safety of rooftop-mounted solar panel systems. As solar energy becomes increasingly prevalent, it's essential to understand the potential risks and how to mitigate them. We'll be reviewing the Need to Know Guide RE3, Rooftop-mounted PV Solar Systems, a document published by the Fire Protection Association, or FPA, in collaboration with RISCAuthority. This guide, released in 2023, provides vital information for anyone involved with solar panel installations, including homeowners, installers, building managers, and safety professionals. It's designed to reduce insurable risk through research, advice, and best practices. In this video, we'll break down the key points of this document. Whether you're considering installing solar panels, already have them, or are simply interested in the safety considerations, this breakdown will provide you with essential knowledge and practical insights. So, let's begin our review of the crucial information within the RE3 guide. To ensure we're all on the same page, let's clarify the scope of this RE3 document. Understanding what it covers and what it doesn't is crucial for getting the most out of its guidance. First and foremost, the document focuses on fire safety considerations for photovoltaic or PV solar energy systems. This is its core concern. In terms of system types, RE3 primarily addresses rooftop-mounted PV solar systems. While it acknowledges ground-mounted systems, its detailed guidance centers on those installed on roofs. It's important to understand who this document is for. RE3 is intended for a broad audience, including those involved in the design, installation, and maintenance of PV systems, as well as anyone concerned with the fire safety of these installations. Its purpose is to provide guidance and best practices to reduce insurable risk associated with PV installations. This document also has important relationships with other resources. It supports and builds upon the recommendations in RISCAuthority's RC62 document, which also addresses fire safety with PV installations, and it cross-references other documents for more specific information. A key example is RISCAuthority's RE1 document, which provides detailed fire safety guidance for battery energy storage systems, or BESS. Furthermore, RE3 considers the main elements of a typical rooftop battery hybrid PV solar system. This includes photovoltaic panels, inverters, battery energy storage systems, and distribution boards. Finally, the document touches on installation methods, such as mechanical fixings and ballast. By understanding this scope, we can better appreciate the valuable guidance RE3 provides and how it fits into the broader context of fire safety in solar energy. Now let's delve into the heart of the RE3 document, starting with its introduction. This section lays the groundwork for understanding the guide's purpose and the importance of fire safety in solar panel installations. The document begins by acknowledging the global prominence of solar energy. It correctly notes that PV solar is one of the fastest growing and most reliable forms of electricity generation. This sets a positive tone, recognizing the benefits of solar power. However, and this is crucial, the introduction also emphasizes that while the incidence of fires involving PV systems is generally low, any electrical installation, if not correctly designed, installed, or maintained, can increase fire risk. This is the core message of the guide. Proactive safety is essential. The document then differentiates between two types of PV systems, rooftop and ground-mounted. For the purposes of this guide, the focus is on rooftop systems, which range from small domestic installations to large commercial setups. Ground-mounted systems are mentioned, but are not the primary focus. This guide is designed to support RISCAuthority's RC62 recommendations for fire safety with PV installations. It's important to note that RC62 covers a range of PV solar equipment and arrangements. The RE3 document specifically focuses on commercial and industrial rooftop PV installations, but its principles are applicable to all systems. RC62 was developed as a joint code of practice by RISCAuthority and the Microgeneration Certification Scheme, with support from Solar Energy UK. This collaboration underscores the document's credibility and its foundation in industry best practices. To provide context, Figure 1 illustrates the main elements of a typical rooftop battery hybrid PV solar system. This includes photovoltaic panels, inverters, battery energy storage systems, and distribution boards. These are the key components we'll be discussing throughout the guide. Finally, the introduction describes the construction of PV modules and the installation methods, noting the use of mechanical fixings or ballast. It also mentions potential issues with ballast if the roof structure isn't adequate. This is a practical consideration that highlights the importance of proper assessment. This introduction sets the stage for a detailed exploration of fire safety in rooftop solar installations. By understanding the document's scope and purpose, we can better appreciate the guidance it provides. In the following sections, we'll delve into the specific fire hazards and mitigation strategies outlined in the RE3 guide. Now, let's move on to a critical aspect of solar panel safety, the potential hazards. This section of the RE3 document outlines the key risks associated with rooftop PV installations. The document begins by noting that PV installations are essentially solid-state systems, meaning they have no moving parts and are generally less vulnerable to wear than traditional generators. However, this doesn't mean they're risk-free. Despite having high individual reliability, PV systems comprise hundreds or thousands of electronic subcomponents. In combination, these components present a significant potential for system faults, which could lead to fires. The document emphasizes that good design, equipment selection, installation, operation, and maintenance are essential to minimizing these components and system failures. This is a recurring theme throughout the guide. Let's look at some specific circumstances that have led to fire losses. Firstly, moisture and water ingress into PV system components, such as DC and AC isolators and combiner boxes, can lead to short circuits and fires. Secondly, a buildup of dirt, especially bird droppings, can cause partial shading, leading to hotspots and faults. Lastly, the failure of poor quality or incompatible components, either from the initial installation or subsequent replacements, is a significant risk. Figure 2 presents a study by BRE from 2017 based on 46 incidents, identifying the most likely PV system components to develop faults leading to fires. As you can see, DC isolators and DC connectors are among the most common culprits. When fires do occur, they can spread between inadequately separated PV panel arrays or via cabling that isn't properly sealed within fire-resistant cable ducts. This highlights the importance of proper spacing and cable management. For systems secured using ballast weights, careful consideration of the roof structure is required. Excess loading can lead to roof deflection and rainwater pooling, potentially causing collapse. The roof's design capacity must also account for snow and ice buildup. Wind and storms can damage systems not designed to resist peak wind speeds or severe weather. Suitable design references such as BSM 1990 and BDG 488 are essential. We've covered the primary hazards associated with PV installations. Now, let's address some additional considerations, including theft and the specific risks faced by fire and rescue personnel. The document briefly touches on theft, noting that while equipment theft from rooftop systems is possible, it's generally less common than in ground-mounted systems. This is largely due to the height of the equipment and the fact that most rooftop systems are located on occupied buildings. However, the document does reference RISCAuthority's S33 guide, which focuses on solar farm security and can provide useful general guidance for PV installation theft prevention. Now, let's turn to a critical safety consideration for fire and rescue personnel. The RE3 document emphasizes that even in the absence of direct sunlight, PV panels produce a DC voltage from daylight and other light sources, including floodlights used at a fire incident. This is a crucial point for firefighters to understand. Even if the AC side of the circuit is isolated, the DC voltage remains present. This continuing production of DC voltage may need to be addressed in the risk assessment undertaken before firefighting commences. As we can see in this image of a solar panel fire on the roof of the Bristol Science Museum in April 2022, understanding these risks is crucial for safe firefighting operations. To help ensure the safety of firefighting personnel and facilitate firefighting, the document recommends the installation of suitably located DC disconnection switches, also known as fire service switches. These switches allow for the remote isolation of the DC side of the PV system. This is considered good practice and may even be mandatory in some installations. These additional considerations, particularly the risks faced by fire and rescue personnel, underscore the importance of comprehensive safety planning and understanding the specific hazards associated with rooftop PV systems. Understanding these hazards is crucial for preventing fires and ensuring the safe operation of your PV system. In the next section, we'll discuss the mitigation strategies and best practices outlined in the RE3 document. Section 3 is the essential risk control recommendations for PV solar installations, part of the document. First, conduct a thorough fire risk assessment. This means identifying potential fire hazards and taking steps to mitigate them. Think of it like a safety checkup for your solar system. Next, consult with your building owner and insurer. Open communication is key. Make sure everyone is on the same page about the installation and potential risks. Obtain a structural engineer's report. This report will confirm that your building can safely handle the weight and installation of the solar panels. Pay special attention to older buildings, mounting methods, and potential roof leaks. If you're using a ballast-based system, make sure it will cause water pooling. And remember, snow and ice loads need to be accounted for. Ensure your roofing materials are non-combustible. Ideally, you want a roof made of materials that won't easily catch fire. If that's not possible and you're installing on a combustible or partly combustible roof, make sure to apply fire-resistant covering. This is crucial for preventing the spread of fire. Choose PV panels made from materials with a low propensity for spreading fire. Look for panels that are less likely to produce burning droplets if they do catch fire. This will help minimize the risk of secondary fires. Ensure the system design and installation follow industry best practices. This means adhering to standards like the IAT PV Code of Practice and using qualified installers, engineers, and technicians. Proper installation is vital for safety and performance. Install a DC disconnection switch, also known as a fire service switch. This allows firefighters to quickly and safely isolate the DC side of the PV system in case of an emergency. Make sure it's located in a prominent and easily accessible position. Remember, this might be mandatory based on regulations or your insurer's requirements. If you have a DC disconnection switch, implement regular switch testing as part of your planned maintenance. This ensures it will function correctly when needed. Implement suitable operating procedures and planned and preventive maintenance arrangements. This includes regular inspections of your PV panels, power distribution equipment, and cables. For commercial systems, an annual inspection by a competent person is essential. And here's a great tip. Infrared thermography is an excellent way to detect potential issues early on. It's a valuable tool for preventive maintenance. Use only OEM appropriate spare parts for maintaining and repairing your PV system. This ensures compatibility and maintains the integrity of your system. Using non-standard parts can compromise safety and performance. Install mains-powered automatic smoke detection linked to the existing building fire detection system in areas where electrical control equipment for the PV system is located. This provides an early warning in case of a fire, allowing for swift action. Consider installing water sprinkler protection. This is highly beneficial for protecting your property. Think about installing sprinklers in buildings with roof-mounted PV systems, especially in areas where equipment associated with the system is located and in adjacent areas that could be affected by a fire. Ensure that sections of PV panels mounted either side of a compartment wall within the building are arranged with adequate fire separation. This is critical for preventing the spread of fire within the building. Specifically, avoid cables passing over the compartment or firewall. If that's unavoidable, ensure they're installed in fire-resistant cable ducts and shafts. B, provide a minimum distance of 2.5 meters between PV modules on each side of the compartment or firewalls. This is to create a fire break. However, this can be reduced if a thorough risk assessment shows a low potential for fire spread. In those cases, a minimum of 1.2 meters separation is required. Suitably support cable runs to avoid sagging, flapping, or lying in areas where water might pool. Cable connectors should be oriented to minimize the chance of water ingress. Regularly check cable routes for sharp edges or other potential damage that could occur over time. This is especially important in our climate here in Britain, where we can experience quite a bit of rain. Ensure that the location of inverters is given careful consideration, with particular attention to providing adequate levels of ventilation. Inverters generate significant heat during normal operation, and proper ventilation is essential for their efficiency and longevity. This is particularly important in ensuring your system operates efficiently year-round in our varying temperatures. Provide specific clear routes to facilitate safe access to the roof for servicing, maintenance, cleaning, and firefighting operations. This is crucial for anyone needing to access your system, whether it's for routine maintenance or in case of an emergency. Think about clear pathways and secure access points. Prepare an emergency plan, including actions to be taken in the event of PV system fires. This plan should ensure A. There is adequate access for firefighters, including good site access for fire service vehicles. This is vital for a quick response in case of an emergency. B. Fire information grab packs are provided for the fire and rescue service at a prominent location. This helps them quickly understand the system layout and potential hazards. Implement systems to avoid accumulation of wind-blown litter and leaves around or beneath PV panels. This is particularly important in our climate here in Britain, where we can get quite a bit of wind. Also, implement measures to control the potential impact of rodents, nesting birds, and other animals that can cause harm and alter the fire safety properties of your PV system. Provide adequate protection measures for prevention of theft and vandalism. Unfortunately, these are things we need to consider. Think about security measures like CCTV or alarms. Ensure that adequacy of lightning protection has been considered. This is crucial for protecting your system from damage during thunderstorms, which we do experience here in England. Implement scheduled cleaning regimes for PV systems, the frequency of which should be based on a risk assessment. A major issue for PV modules is bird droppings, which will adhere to the modules irrespective of angle. Cleaning should be undertaken by suitably trained personnel who follow a detailed risk assessment method statement, or RAMS, for this work. And finally, number 22, provide adequate ground level signage where PV systems on a building are not obvious from ground level, clearly visible for the fire and rescue service on arrival. This helps them quickly identify the presence of solar panels and understand the system layout. And finally, we come to the references. These are the documents and standards that the FPA and RISCAuthority used to compile this comprehensive guide. If you're looking for more in-depth information, these are the resources you'll want to explore. These references provide a solid foundation for understanding the best practices and standards for rooftop solar PV systems. If you're serious about ensuring the safety and efficiency of your installation, I highly recommend checking them out. You can find these resources online or through professional organizations. So let's bring it all together. We've covered a lot of ground in this guide from the FPA and RISCAuthority, and it's absolutely crucial for businesses considering rooftop solar PV systems to take these recommendations to heart. Here's why. Safety first. The guide's primary focus is on mitigating risks, especially fire risks. A fire on your commercial property can have devastating consequences: loss of assets, business interruption, and most importantly, endangerment of lives. Combustible insulation. A critical concern. If your building has combustible insulation, the risks are significantly amplified. This guide provides specific measures like ensuring non-combustible roofing or applying fire-resistant coverings that are essential to address this increased risk. Ignoring these recommendations could lead to a catastrophic outcome. Compliance and due diligence. Adhering to these recommendations demonstrates due diligence and helps ensure compliance with relevant regulations and insurance requirements. This can save you from legal and financial headaches down the line. Long-term reliability. The guide also emphasizes maintenance and operational procedures, which are vital for ensuring the long-term reliability and performance of your solar system. In conclusion, this guide isn't just a set of suggestions, it's a roadmap for responsible and safe solar PV installation. Before you even think about installing those panels, especially if your building has combustible insulation, make this document your go-to resource. It will help you make informed decisions, prioritize safety, and ultimately reap the benefits of solar energy with confidence. Thank you so much for taking the time to watch this video. I hope this breakdown of the FPA and Risk Authority Guide has been helpful. Remember, safety is paramount. Please like, share, and subscribe for more informative content. If you have any questions or experiences to share, please leave a comment below. Stay safe and let's embrace renewable energy responsibly. Take it easy. All the best.